Okay, so as we discussed in the first class, if you have any if you have any question, please write in the chat your question or just write question maybe. Then I will give you a chance to ask. Okay, so about yesterday's guest lecture, yes, I understand it was a bit more maybe. Uh, so the material was interesting, no doubt, but possibly it was a better suited to maybe the computer organization architecture course or something. But at least it is good to have some perspective from a person working in the industry, because often we in academia we tend to miss that. So we study different subjects separately, but like a person working in the industry actually sees the whole pipeline about how a chip is built or um, how these kind of processors work. So I hope you have learned something for it. I mean, even if it's okay if you have not understood everything what was told yesterday, and that is not part of the syllabus or anything like that, but hopefully it was some exposure into what goes on in a top industry like Intel. Okay, so today we start with our introduction to operating systems. So in operating systems, I think all of you know that we will use the abbreviation OS. And so today what we will discuss are basically some high level questions without going into much details, like what is an OS, what are the goals of an OS, then under the hood, the structure of OS. Of course, this is something which, okay, so these two questions are something that we will study throughout the semester. But today I'll just maybe introduce them and give some food for thought about, uh, I mean, how could an OS work? Okay. So let's start with the first question. What is an operating system? Now, let us understand that this is not a concept in physics where I can give you a precise definition. Right? So in general, I think you know that, I mean, it's intuitive that something as complex as operating system will not have a single simple definition. But let's still try to describe what it does and so on. So let's start with enumerating the actors. That means the people or the entities. I should not say people. The entities who are kind of using the operating system or are affected by the operating system. So first are users. Okay, that means any user of a computer system like you or I. Now I think you know that there can be one or multiple. So suppose you are using a laptop, then there is only one user using the whole system. But when you when you log into the departmental servers and work, there many people are trying to use the same machine. So maybe what you have in front of you is a client. That means is a small machine which only one person is using. But actually that client is connecting to a server which many people are using, right? So this situation is quite common, like in the departmental labs, you access the departmental servers and work. What is another example of, say, working on a server, which all of us do? Can you say? Say means please write in the chat. Another example, daily life example where we use servers. I mean servers which actually many people are using together. Yes, web pages. Exactly. So web pages, online shopping, even mail, even Gmail. So all these things which we are using. Maybe the computer that we are sitting in front, we are only using it. But actually when we are opening up a website on our browser, our browser is connecting to a server, a remote server. So therefore, and say at one point of time, maybe 10,000 people are shopping on Amazon or 50,000 people are checking mail at any one point of time. So you can think that the Amazon server or the Gmail server is being accessed by many people together. Now, exactly how the remote server is used, that is not part of this course. In fact, that will be covered in the networks course. So you are learning networks in parallel, right?
Yes, sir.
Okay, fine. So yeah, so how a remote server is connected, that is not the part of this course, but the thing to understand here is actually there are many machines in the world which many people use together. So those are the users, maybe one or multiple. What do the users do? They log in and they start applications. Like someone might, I mean, applications are also different. Some user might be writing a program on GCC, sorry, compiling a program on GCC, or writing a program on Notepad or gedit. Some other user may actually browse using Firefox or Chrome. Someone else may be working on Excel. Okay, please keep yourself muted, everyone. Hello, please keep yourself muted. Okay, so yeah, so the users log in and start different applications, right? This actually a single user can also do and multiple users can also do. So we know that even when we are a single user using a laptop, we can actually start many applications and work on them. Now, these applications ultimately need to use the resources. That means the hardware. Typically, what hardware a computer contains, I think all of us know from common knowledge, like say the processor, RAM, display, mouse, keyboard, and so on. Right. So at present, if you have 5 applications open, maybe all 5 need to access the display. Definitely all 5 need to access the RAM and processor and so on, right? So all the applications need to access the hardware. The operating system's role is this. It sits right in between the applications and the hardware. So it enables the applications to use the hardware. Okay. We will discuss much more on this. How? So this is a schematic diagram taken from this book by Kelvin. So if you see at the bottom, there is computer hardware. And at the top, there are users, let's say multiple users logging onto a server. And different users have started different system and application programs. Compiler, assembler, text editor, database, browser, video, uh, like video program, video running programs, and so on. The operating system, if you see, is sitting in between the system or application programs and the computer hardware. So basically the OS is enabling the programs to use the computer hardware. So one particular definition of OS could be that a program that acts as an intermediary between users of a computer system and the underlying hardware. Note this is one definition. We will soon see more. Right. So this is a kind of a uh, this is a a definition of OS which talks as about its position in say the computer system. So it is acting as an intermediary between users and the hardware. I mean, going into a bit more detail, the users of a computer system actually start up different application programs. So the OS acts as an intermediary between those application programs and the hardware. Right. So, so hopefully you have got some idea of what an OS is. Next question is, what are the goals of an OS? So the primary goal of an OS is to make the computer system convenient and easy to use for the users. Okay. So what does it mean? So there are many aspects of making it convenient and easy. So let me tell one aspect. You don't need to worry about the hardware details, right? So you don't need to worry about exactly which processor is being used in your computer, how much RAM is there. Say tomorrow, let's say that the RAM of your machine gets damaged. You simply go to the market and or order online another RAM and fix it in. Who knows? Maybe the previous RAM was from one company, this RAM is from another company. The idea is that you don't need to worry about these details. The operating system will create an abstraction kind of thing, which will make you able to use the computer system without worrying about the hardware details. Right? So it makes the computer system convenient and easy to use. So, and in fact, I mean, I think you get the idea, like you say, all the servers that you use, the remote servers, including the departmental servers, the web servers and all. Do we ever worry about how much hardware they have, how much RAM they have, how many users are logging in together, whether it will be able to support so many users? Ideally, we don't need to worry. Right? Sometimes if the load becomes too much, then problems happen. But then ideally, we can use a computer system without worrying about so many details. Also, it ensures efficient utilization of resources. The operating system. Another goal is to ensure efficient utilization of resources. And when we say resources, we mean processor, time, printer, RAM, and so on. So understand so basically again, intuitively, let's say all these computer systems could be used by only one user, then things would be much more simple. Trust me on this. If every computer system has only one user, things would be much more simple from a system point of view. Then why do we want multiple people to use a computer? Any idea?
So can you please repeat the question?
I'm saying the world would be much simpler if every computer system has only one user. They will run one program and so on. So at one point of time, only one program will be running. And trust me, the very older days, computers were like that. But nowadays, we want many people to use a computer, let's say a server, together. Why? Okay, Rajat says seamless sharing of resources. But Rajat, understand, that is something we have to ensure. Seamless sharing of resources. I'm asking a more fundamental question. Why do we want multiple people to share resources? Whether we'll be able to make it seamless, that is a different issue. Why do we want multiple people to share resources? Okay, Nisarg says high cost of creating so many computers. Okay, that is definitely one part of the answer. Any other answer? Okay, I see multiple people say high productivity or increased productivity. What do you mean? Maybe Satwik?
Sir, so if we only open one program at a time, it'll be difficult to like multitask. So
why do you
we'll
need
be
to multitask? Oh, you are saying that, okay, so a user may want to actually run multiple programs together.
Yeah, that was part
Yes.
of the question.
Yes, that is part of the answer, right? Anything else?
That's the point I wanted to make.
Okay, fine. So this is correct, that multiple nowadays, I mean, at one point of time, maybe we were happy running one program at a time. Now, of course, we want to run multiple applications together and so on. There is another point which, like, maybe you did not think of. Modern day resources are extremely powerful. Say a modern day processor. If only one person uses a modern processor, it will be underutilized. Because human beings cannot actually work so fast. The human brain cannot work so fast that it can utilize the whole processor. Right? So, processors are costly. So you pay money to buy a processor. Now, if you have paid money to buy a good processor, you would want to utilize it. No one wants to spend money on a resource and then not utilize it. So it's like, say, you could have bought a cycle just for your use, but you bought a car. So you spent more money. So in that case, you might like your family also to travel in the car. You won't only travel alone. If we are paying more money to buy a better resource, we want better utilization. So similarly, modern day processors are costly and they are extremely powerful. One person will not be able to utilize the power of a processor fully, even if multiple programs are run. Therefore, the processors in these servers, extremely powerful processors, we want multiple people to share those resources so that they are utilized better. So, but now the question comes like what was said. If multiple people are sharing a resource, we need to make this sharing seamless. So ideally, every person, say 10 people are sharing a computer, 10 people are using a computer. I mean together at the same point of time. Ideally, each one of those 10 people should think that he or she is the only user. Let me repeat because that is an important point which will come throughout the semester. If 10 people together are using a computer, let's say a server, the idea is, or the optimal condition is, that each one of those 10 people thinks that he or she is the only user of the computer. Okay. So that kind of seamless sharing of resources is managed by the operating system. Okay. Again, how that we will discuss throughout the semester, but yeah, that is one of the primary goals. So these are the two goals. One is the user side, make it easier or simpler for user to use the systems. The other is from the resource side, ensure better utilization of resources. Now, the interesting thing is that these goals may actually be conflicting across various types of computing systems. Let's see the genesis of computer systems quickly. So in 1970s and 80s, we had mini computers and mainframes. Maybe some of you have read about them in History of Computers or something. That the big machine, so built during, say, World War II and so on. EDVAC, ENIAC, and so on. So then, resources were very, very costly. So the only goal of such machines was best utilization of resources. Because if resources are very limited, you want to utilize them, whatever is available. At that point, no one cared about user experience. Okay. So let's say you have one machine, and actually that was the case. Like I have heard my father say that when they were students, there was only one computer in the whole of Eastern India. There used to be a computer center in Calcutta. So there was practically that one computer. So people from other institutes used to go to that machine. And remember, there was no internet, etc. I'm talking about maybe 70s or yeah, 70s or 60s. So people used to go to that institute and actually submit their programs on punched cards. Maybe some of you just have heard the name of punched cards. Then they would come back because maybe 1 week later they will get the output of their program. Because there's a long queue, right? Maybe 100 people have submitted their programs on punched cards. The machine will run them one after another. And maybe 1 week later they will get the result. So at that point, because resources were very few, only goal was utilization of resources. No one cared about user experience. Then in the 80s came workstations or terminals, and they are continuing even now, like the desktops and things. So here was the idea changed. The idea was the user experience is important. So fast response time. And typically one user used the machine. So that one user got fast response time. But then the other goal, that is resource utilization, was sacrificed. Right? Because one user is using the whole system, even if that user is not working much, or maybe that user is just opening one program, I mean, it was acceptable because people cared more about user experience and much less about resources. So you see a complete change of stance. In 1970s, resource was very expensive, so people thought only about resources and not about user. 1980s, small workstations became cheaper, so people started worrying about only user experience and not resources. This trend actually continued to laptops, right? So again, flexible UI, easy to use, we want all these, lightweight, but cost is single user system. So typically I have never seen a laptop being shared by multiple people. Maybe yes, nowadays even a laptop can be used as a server, but yeah, I mean, typically, I mean, when we're using the word laptop, we usually mean one person. So again, the goal is user experience. I mean, improving user experience at the cost of the resources. And we have even gone further to have mobile systems. So now we have multiple considerations. One is definitely ease of the user. So the good UI, good easy to use. But then we have reduced the resources to so much that now we need to worry about some types of resources like battery life or even the processor. Like you cannot expect a mobile system to have a processor as powerful as a desktop. So now again, we have reached the stage where we have to worry both about user experience as well as the optimal utilization of resources. Right. So as you see, I mean, there is nothing wrong in either of these. This is just the nature of the times. At different times, different things get priority. So that is the same here. Right. But as you understand, the two goals, the two broad goals of an OS, that is making it easier for the user versus better utilization of resources, they can actually be conflicting in different types according to the particular system being used. Also, so the previous slide says the goals might be conflicting across the type of computing system. Okay. Another thing to understand is the goals might be conflicting across applications. Say you have a particular machine and you have multiple applications running on that machine. So application A says I need 3 GB of memory now. So basically as if the application is telling the operating system. Remember, the operating system sits in between applications and the hardware. So the application program cannot directly access memory. It has to ask the operating system to give it some memory to use. So remember that, I mean, since all of you know programming well, we have studied things like say static allocation, dynamic allocation, right? So during dynamic allocation, it is very explicit that actually your program is asking for more memory, right? A malloc or a calloc. So whom does it ask? The operating system, right? So your application or your program is asking for more memory. Now let's see that in a particular machine, application A says I need of 3 GB memory now. At the very same point, or just after that, application B says I need 2 GB of memory now. However, the total RAM in your machine is 4 GB. Okay. So what can be done? Simple option, do not allow multiple programs to run. Okay, that would be the simplest, but we don't want that because we want to utilize resources. So then what to do? I'm not answering that question now. That we will answer throughout the semester. But understand that, I mean, these kind of things can easily happen. So the goals can be conflicting across applications also. Different applications need different types of resources. Okay, Satwik says something, but I'm not going into any technical details right now. So, I mean, what Satwik has said is just one part of a big picture. So let's not go into the big picture right now. That we will have a whole chapter. Maybe we will spend 2 weeks on this question about how memory can be shared between applications and so on. So let's leave it for later. Okay, so now throughout this discussion, you see that now we can give a second definition of OS, which is a goal-oriented definition. So typically OS has two kinds of goals. One is a resource allocator. So it manages all resources in the computer system. By resources, we mean processor time, RAM, display, etc. And it manages all resources to ensure that they are shared in an efficient and fair manner. Okay. So basically it decides which application gets how much resources and when. Also, the OS works as a control program. It means it controls the execution of other programs or applications to prevent errors and improve usability. Okay, so this is important. The operating system controls the execution of other programs or applications to prevent errors and improve usability. So there are multiple programs running together of multiple users. We should not allow the program of one user to disturb the program of another. Right? So let's say a faulty application which does something illegal should not be allowed to disrupt other applications. Okay, I have a question here. Does this remind you of something? This particular point or something which maybe right from your PDS days you have experienced. Does this remind you? Okay, see, again, it's a request. Please don't start talking suddenly because it kinds of breaks my momentum. Okay. So like in a physical class also, you would not start talking suddenly, right? You would raise your hand. So again, please don't start talking suddenly. I mean, maybe it's my limitation that I cannot. I get disturbed if someone suddenly talks, but then please don't do that. Please write in the chat. I can understand writing again is okay. I mean, again, you have to write. But yeah, in the online class, online environment, we have to have some costs, right? Okay, fine, Sadvik, that's okay. Yeah, okay. So the exact answer that I was looking for is given by Aryan. Exactly. Segmentation fault. So Aryan, can you unmute yourself? So why do you think a segmentation fault occurs?
When we try to access a memory like which is not present or by dynamic pointers.
Sorry. When we try to access a memory, which?
Sir, like which is like not allocated, like the memories.
Right. Perfect. Yes.
Or by
Yes.
dynamic pointers.
Exactly. Good. So yes, very simply put. Again, see, let's say there are multiple programs running, so they all are sharing the memory. So some part of the memory is allocated to your program, some other part of the memory is allocated to another user's program, and so on. Now your program should ideally only access the part of memory allocated to you or your program. If your C program tries to access some memory which is not allocated to you or your program, the OS prevents it from doing so. The reason is this: your C program should not be allowed to disrupt other programs. Okay, so that is exactly why a segmentation fault occurs. So again, understand that your program directly cannot access memory. Your program has to ask the operating system for access, and the operating system checks like what memory are you wanting to access. If it knows operating system itself has allocated the memory to your program, so it knows which part of the memory is allocated to you. If it sees that you are trying to access, okay, please keep yourself muted, everyone.
ఏమో అది ఊరిలో ఉంది కాకపోతే మధ్యలో ఏదో ఉంది నాకు అర్థం కాలేదు.
Hello.
Yes, you are audible.
Okay.
I think the student muted himself. Satish, please
Someone
go on.
mute.
Yeah, fine. Okay, thanks. Okay, so yeah, so basically the operating system knows which part of memory is being allocated to you, and it checks whenever your program tries to access a memory. If it finds that your program is trying to access a memory not allocated to you, it will stop. And that leads to a segmentation fault. And basically your program, you must have observed, if a segmentation fault happens, your program stops running. Right? So that is what the OS does. Okay. Also, OS has several other goals, which we will study in more detail over the course. Sometimes one application may need to communicate with others. Right? So in the same computer, one application, so multiple applications are running, one application needs to communicate with others to share data, state, etc. We will see such examples that such communication or coordination is also enabled by the operating system. Also, this is an important point, enabler of easy development of applications. Now again, see, we are not, so you all are studying a computer science course for 4 years. Clearly, you do not only want to be limited to using applications. You actually want to develop applications also. Many of you might actually be doing that also already. So this is another important role of the OS, that not only using applications is simplified, but also development of applications is simplified. How? The OS offers a set of common services for applications. Right? So let's say you are designing an application. Now don't think you are using an application, but you are designing an application. So you need to write your application in such a way that it will access memory, it will access the processor. Right. In fact, the C programs that you write are actually applications, right? We write C programs so that others can use it. Forget the PDS lab where maybe only you are using your program, but typically we write programs so that others can use it. Now, while writing a program, you don't need to worry about the details of how much RAM is there, etc. Let's say while you are writing your C programs, did you ever worry about how much RAM was there in the computer? I guess not. We just allocate big arrays. We dynamically allocate huge matrices. We don't worry about how much memory was given to us, how much memory is there in the machine, how many other programs are running. Right? We don't need to worry about these things while we develop applications. So basically, the operating system is giving us an illusion of infinite resources. So you can write a program thinking that you have infinite resources. You don't need to worry about RAM or how many other programs. How much RAM is there? How much? How fast the processor will run, etc. You don't need to worry. Right. So typically, say, I hope you understand, during say PDS lab days or even during other courses, maybe all 130 of you logged into the same server and used your program. But then you never had to worry about the other 129 students. Every one of you thought that you are the only user of the computer system. So you can just write your application without worrying about other users, without worrying about how much RAM is there and so on. Right? So this illusion is created by the OS that everyone can think that they have infinite resources. Okay. So I see Mainak has a comment. So let's just read it for some time. So yeah, I think this is in, so Mainak, maybe you would like to explain?
Yes, so because we are talking about the role of operating system, and Saptarshi already gave the example of if an application A is asking for 2 GB of memory or 3 GB of memory, application B is asking for 2 GB of memory, how to handle that, because the total RAM is only 4 GB. And then I guess one of you, Satvik, actually pointed that it is swap file. So many of you who have installed Linux or even who have seen Linux system, know there's something called swap space that you need to specify, which is something that we will talk later. But what I wanted to point out that even just like you're talking about scheduling and sharing of processor in the last class, even in this class, just like that, memory sharing is something which is key component of operating system, and that is the reason, and we'll know that how the operating system would share memory, but that is something that the memory management unit of operating system in some sense is one of the things that gives this illusion of infinite memory. So the application will know that they can have as much memory, like if they are asking for 2 GB, 3 GB, 10 GB memory, they will get it. But ultimately the operating system will translate and share the actual physical blocks that is in the hardware, in the RAM, and map it to those 10 GB memory space. And the key there is that operating system has to need to do that smartly, need to do this sharing smartly, without assigning the same physical memory space to two applications. That will be all over to you, Satoshi.
Fine, thanks, Mainak. Yes, so as Mainak said, we will study these. It's okay if everything is not clear, but we will spend quite a few classes on how memory is shared. Okay, so now I hope you have understood or get some glimpse about what are the different roles or goals of an OS. The goals of an OS are to make things easier for the users of applications, for the developers of applications, as well as to ensure efficient use of resources. Okay. Now, let's go a bit under the hood and understand the structure of OS. However, by structure, we simply mean control flow. That means don't think that we will actually show you code of OS and so on. We actually mean control flow. So just like you understand control flow of a program, like from what to where does control go, from which module to which module does control flow and so on. That is what we will discuss. So now we will introduce a new term. Till now, this is the picture that we have, right? So applications and hardware, the operating system sits in between them. So applications have to access hardware through the operating system. Now we will introduce a new term called kernel. Okay, what is the kernel? It's the collection of functions that provides essential functionalities of the OS. Okay, so kernel is actually a part of the OS which provides the basic functionalities, the fundamental functionalities of the OS. So what does that mean? What about the rest of the operating system apart from the kernel? There are these other OS components which we use, like the shell, the GUI, the services or system tools. The GUI is what you see. The shell, I think, hopefully, while working on Linux systems, you have used the shell. So we can give commands to the shell like ls, mkdir, and so on. So those are also, if you think, a part of the operating system, sure. But then we differentiate between the outer parts of an operating system, like the slightly more like surface level components like shell, GUI, etc., and the kernel, which is the fundamental part of the OS, which provides which is the one which helps to, access the hardware. So the kernel is the part of the OS which is closest to the hardware, and that is the part which handles functionalities such as managing the memory, the network, files, processes, system calls, and so on. So the other parts of the OS can interact with the kernel whenever they require these functionalities. So for example, we all have used things like scanf, printf in your C programs. So what are they? Scanf, printf, what are they? Are they part of the operating system proper? In one way you can say yes, but still, are they part of the proper operating system? What do you think? Scanf, printf. From this slide, it is clear that they are not actually part of the system, operating system. But then what is their part of? Scanf, printf? They are programs. Okay. Okay, that way anything is a program. So that is, I was asking a bit more technical answer. Okay, Anuradh says they are system code. Okay, Anuradh says, okay, no. Yes, Anuradh and Satvik say that these make system calls. Agreed. But what are they? What are they themselves? Scanf and printf. Exactly, Rajat has the answer. Printf and scanf are C standard library functions. That way they are not part of the kernel, the central part of the OS. They are standard library functions of the C library, which are actually wrappers. So that means if you actually see the code of printf, right? So maybe some libraries, a standard library that has stdlib, that has printf scanf, right? If you actually see the code there, you will see that they make other function calls, which are called system calls. We will study them in detail. By using those system calls, they actually use the kernel. Okay. So again, let me go back to the previous diagram. So the C library, the C standard library is somewhere in this green part. It is, you might say, in fact, I would say, I mean, okay, whether it's an application or operating system, green part. So Mainak, what do you think? The C standard library, would it be in the yellow part or the green part?
So, okay, I would like to actually know what the students think. How many things that it is in the applications layer, and the one, how many of them you think they are in the OS layer, just the standard library functions. The standard library is basically stdio.h, same like that. Application, okay.
So we have both
OS,
opinions.
We have 50-50%. Okay. For Windows is in the yellow part. Okay. Yes and no. Nice. Okay, so the stdio.h, the C standard library functions, they are definitely in the applications side. So you can still delete that header files and everything. So the wrapper that Ritesh was talking about, they are definitely just wrappers, right? I mean, you can write the wrappers using system calls from user space. So it is, yeah. Yes. So essentially, the wrapper itself will be in the application space. However, the calls that they make, like scanf, printf, or making system calls, or whatever fancy things, essentially, that is what we call using operating system as an API, as a like huge set of functions. Those functions are part of the green zone, essentially.
Right, and again, understand why so much complexity. I mean, there can be multiple reasons, but one way is that, see, when you write a C program, you would like it to work both on Linux and Windows. So if it was your responsibility to actually call the low-level functions, then you would need to know what are the low-level functions of Linux. Next day, if you want to run the same program on Windows, you'll have to change your program and so on. Rather than that, you are getting a unified abstraction, kind of. So you can just call printf scanf. The same code will make different system calls possibly in Windows and in Linux. And thus you don't need to worry about those low level details. So that is why we have this layered kind of architecture. Right. Okay, so okay, so actually, yeah, it's 10 o'clock. So let me stop here. We can continue with this next class. Fine. So any questions right now? Fine. Okay, then. Thanks, everyone. We will continue again next week.